Hello. So welcome to this Pi Day video, or that's the Friday the 13th. I'm going to show you how I calculated pi in a pretty unique way in this video. So I used the Monte Carlo algorithm, but I powered it by humans. And if you want to know the exact mathematical stuff behind the Monte Carlo algorithm, you can look that up later. I will explain it in a simple and in my own terms later in this video. But if you want the actual rigorous definition, go look it up. So I had however many friends submit different pairs of numbers, random pairs between 0 and 10. So x can't be outside 0 and 10, and y can't be outside 0 and 10. Divided all these numbers by 10, and then I got this scale from 0 to 1. And I graphed all these little pairs. Then I put a circle here, and I then divided the amount of dots inside the circle by the total amount of dots, and then multiplied by 4, and then I got this value for pi, 3.082, which is not bad. It's a 1.9% error. Actually really good, considering it was just powered by people guessing random numbers and then me drawing a circle and then dividing. That's, for pi, that's insane. So how does this math work? I will show you. So let's say I take an infinite amount of dots and I cover them in this square, which is 1 by 1. Okay. So the area of a circle, as we all know, is pi r squared. Pi r squared. So another way to represent the area of the circle is the area that the red dots take up of this square. Now this square is 1 by 1. So the area in red is going to be equal to the total area times the ratio that the red takes up, which is going to be number of red dots, roughly, divided by the total number of dots, so red plus green. So this red plus green is the same as this capital blue T. And so then in this scenario, red plus green is not equal to this total blue T. This total blue T is equal to 1, because it's a length of 1 by 1, so 1 times 1 is 1. And then times, however many red dots I got, which was 50 something, 50, 54 or so. And then divide by 61, and it came out to roughly 0.77. So then this means that area equals 0.77, which means that pi equals this ratio, by the way, since we made our square area equal to 1, square area, this ratio divided by r squared. Now, r in this scenario is 1/2. The radius of the circle is 1/2. And so then r squared is 1/4. And if you're dividing by 1/4, you're just multiplying by 4. So 4 times 0.77, and we get this, 3.08. See? 4 times 0.77. See? So if you have, you just get a bunch of people to guess random numbers between 0 and 1, I did 0 and 10, so it was easier for people to guess, just say random numbers. And then you divide the amount of numbers that end up inside this circle that touches the bounds that you gave. The radius is half the bounds that you gave, so my radius is 0.5 because the upper bound is 1. And then you divide the amount inside by the total, multiply by your area of the square, but I would just keep it at 1. Then you divide by r squared, and you get pi. Now the issue with this one is that, it's not a very clever way of doing it because, there's so few spaces for this to take up that you're going to get repeats and stuff. And also, after you get enough people, it's going to like it won't increase in accuracy anymore because there's only so many squares, like 100 different points here, and so or actually over 100. It's like it'd be never mind. It's like a very finite amount. So once so many people answer, then it just loses. It stops developing accuracy. So you would need a more fine, like you did guess through 1 through 100, and then divide by 100 on your thing, and then you keep doing that, and that might make it more accurate as more people go on. But that just makes it less fun for people to guess the pairs because, people are much more akin to guess pairs of single-digit numbers than they are to guess pairs of like triple-digit or 10-digit numbers. Not digit numbers, tens-digit numbers. So there's that, and also I try to account for duplicates, like duplicate pairs, in this to introduce human bias because otherwise it really is just seeing like the limiting factor is how many friends I asked. Because if I ask enough, then I get an infinite amount of like I get the maximum amount of accuracy that I could if I ask enough friends because the maximum isn't really that high. um, but yeah, that's how I calculated pi using just a bunch of people and a circle. Happy Pi Day!